Hello, this is Mr. Spy, and now we're going to look at this last video in our set of power functions, where the coefficient is less than 1, mainly emphasizing -1, and seeing how it affects a power function. When you make the function negative, it reflects the function over the x-axis. So a simple case, we look at x squared, and the negative x squared, it flips it over the x-axis. Doesn't matter if it's x squared or x to the third, it flips it over that x-axis. Doesn't matter if it's a positive power or negative power. It's a positive power, it's in the first and third quadrant. When it's negative, it's in the second and fourth. Same thing with a squared. If it's usually in the first and second quadrant. When it's negative, it's now in the third and fourth. This, instead of being above the x-axis, now below. This would also flip over. It doesn't matter what shape we use. It really does not matter what shape we use. Really does not matter. That's the effect a negative has. Now, how do you reflect over the y-axis? I just look at the simple case, x to the third power. So I want to reflect over the y-axis. You make the x itself negative, and that flips it over. It's interesting when you see negative exponents. What it does doesn't do much different, but if you start looking at the half power, that flips it over to really emphasize what happens when we have our fractional exponents. That's when interesting things happen. If you make it a double negative, we'll put it into the third quadrant. So you could actually have your function travel through all 4 quadrants when it's a fractional power with an even denominator, and see the different types of reflections. Reflection over the x, in the y-axis in this case, reflection over the x-axis, and reflection over both. Okay. Hope that was helpful looking at the explanation of what a negative coefficient does to a power function. It reflects it. That's what negative coefficients usually do. They reflect. We're not going to look at rotating it. You cannot translate a power function up, down, right, or left because it has to pass through the origin in order to be a power function. Once you translate, it's no longer a power function. Ends up being either a polynomial function for even and odd, or linear. If it's a negative, it becomes a rational function. And if it's a fraction, it becomes a radical function. So based on what type of power it is, by translating, you actually change the function name from power to something else. I hope this was Mr. Spy. I hope this all helps for you. This is Mr. Spy. I hope this explained power functions better to all of you and the different types there are of the 9 different types gone over in the first video, and the effect of a positive coefficient gone over the second view of a dilation, and the third video of a reflection based on the coefficient being negative or the x value itself being negative. In the next set of videos, I'm going to look at how to find the exponential equation given 2 points where you don't know the y-intercept. That'll be a set of 1 video going back to the previous set and 3 videos practicing the next set. This is Mr. Spy. Subscribe to my channel and signing off.